I would like to greet Dr. Wong Sing Yun. My name is Nurul Shafika binti Hanif with matrix number BB221100092. I will present to you the first part, which is construct appropriate graph or charts to compare the relative frequency and cumulative frequency between the two metrics. Okay, so I choose to make a group data, which is I do the class interval for the e-commerce data for both metrics, the number of visits in million and the number of purchase order in million. So as you can see, the class interval for number of visits is by 5 and the class interval for purchase order is by 15. So I use Excel to find the frequency. How I find the relative frequency? So the formula is for the first class interval, you can take the first frequency and divide it with the total, so you can get the first relative frequency. For example, you can take 3, you divide it by 30, so you can get the first relative frequency, which is 0.100, and continuously until the end, until the last class interval, and the total would be 1. So as for relative frequency, number of purchase order, same as number of visits, where I take 5, the first class interval frequency 5, I divide it with 30, so I get 0.167, which is the first relative frequency. And the relative frequency for purchase order will continuously using the same formula, same as relative frequency for number of visits. So as you can see, the grand total for relative frequency must be 1. How do I find cumulative relative frequency? Okay, so for the first cumulative relative frequency, I just put it 0.100, which is same as the first relative frequency because there is no number before the first class interval. So I just take the number, the whole number, to put it on cumulative relative frequency. Okay, so how do I find the second cumulative relative frequency? 0.133. Okay, so the formula is where you take the first cumulative relative frequency or the before data that you want to calculate, which is 0.100. So you plus or you sum up with 0.033, which is the second relative frequency. As you can see, I put the arrow there. So you can get 0.133. So same as the third one. So as for this one, you can calculate it and continuously add, and then the last class interval must be 1. So same goes for number of purchase order, where you have to use the same formula, but you use the data from purchase order. Okay, so how do I get 0.167? Same as the number of visits. I just take the relative frequency for number of purchase order, 0.167. I just put it on cumulative relative frequency, 0.167 for the first class interval, since there are no data before that. Okay, so how do I get the 0.300, which is the second cumulative frequency? I just take 0.167, the first data for cumulative relative frequency, just sum up with the second data for relative frequency, and then the total would be 0.300. So it will continuously until the end of the class interval. The cumulative relative frequency for the last class interval would be 1. So here you see relative frequency and cumulative relative frequency. I choose 3 decimal point for the answer. Okay, so you see here, as for the relative frequency, I choose a histogram to compare the data between the two metrics. For cumulative relative frequency, I choose ogive to compare the both of the data between the two metrics.
I am Susan Chu Yingling, who holds student number BB221105111, will present the answer to Part 2. Calculate and compare measures of central location between the two metrics. There are 3 ways to calculate the measure of the central location, which are using the mean, median, or mode. The formula for mean is the sum of all the data points divided by the number of data points. Symbolically, the formula for mean can be written as in the slide of the presentation, as xi are the data values and n is the number of values. The median is another measure of central location that is not affected by outliers. When the data are arranged in ascending order, the median is the middle value is the number of observation is odd, or the average of the two middle values if the number of observation is even. Symbolically, the formula for the median can be written as in the slide of the presentation. The mode is another measure of central location, which is the most frequently occurring value in a data set. By using the mean method to calculate the measure of the central location, the number of visits is 1131.4 divided by 30 equals 37.71, and the number of purchase order is 5004.5 divided by 30 equals 166.82. By using the median method to calculate the measure of the central location is on position number 15. So the number of visits is 34.1 and the number of purchase orders is 163.3. By using the mode method to calculate the measure of the central location, since the mode is the most frequently occurring value in a data set, the number of visits is 34.1 and there is no number of purchase orders.
Hello, my name is Joshua Junin Nasil. My metric number is BB231103A3. So for this group assignment, I will be doing the part 3, which is calculate percentiles and construct box plot for each metric. The formula that I will be using to construct the box plot and also finding the percentiles. The question is ascending or descending. So the answer is ascending. Why? Because on the top of the data for number of visits and also the number of purchase order is showing the smallest value for the data. But if you slowly scrolling down, you can see all the number is growing up. So on the bottom of the data is showing that the maximum value for each data. What is the 5 summary value for this data? It is minimum, maximum, quartile 1, quartile 2, and quartile 3. So in the left side of the calculation, you can see the number of visits. So you can see all the calculation for the first quartile, second quartile, and also the third quartile. And on the bottom of the calculation, you can see the value for the minimum and also the maximum. Same thing happen in the number of purchase order is on the right. You can also see all the calculation as same as the number of visits. You can see that I already construct two of the box plot. The left side is for the number of visits and also the right side is for the number of purchase order. So the box represent the middle 50% of the data, and the bottom and top edges of the box is quartile 1 and the third quartile. This shows the spread of the central of the data. And the line inside the box is called median, or in other words, called quartile 2. This helps to identify the central tendency of the data. Whiskers. Whiskers is the line on the left and also on the right side of the box. Whiskers show the range of the data. So the bottom of the left side of the whiskers is showing the minimum of the data, and the top of the right whiskers showing the maximum of the data. The purpose of these box plots are useful for comparing the distribution of different data sets and also to help identify skewness, central tendency, spread, and also potential outliers. These are the calculation for the interquartile range and also the outliers. First, you need to find the interquartile range so that you can use the interquartile range into the outliers formula to find the low outlier and also the higher outlier, or in other words, upper limit and also the lower limit. And you can see the value for each upper limit and also lower limit for the number of visits and also the number of purchase. So do we have outliers? So for the number of visits, there are no outliers because all the value in the number of visits is between the lower limit and also the upper limit. But in the number of purchase order, there are one outliers, which is the Shopee, because the value for the number of purchase order for the Shopee is 231.9. This is above from the upper limit, which is 226.33. What is the type of skewness for the box plot? Skewness is a statistical measure that describes asymmetry of a probability distribution. There are three types of skewness: positive, negative, and also zero. So I have determined that the both of the box plot for number of visits and also the number of purchase is positively skewed. Why? Because the median is left of center and the right whisker is longer than the left whisker.
Hello everyone, my name is Faizi Afandi bin Muhammad Fauzi and my metric numbers is BB23110487 and my part is part 4, which is calculate and compare measures of dispersion between the two metrics. For formula, this is 5 formula we can use to find measures of dispersion, which is the first one is for range formula. The second one is for the mean absolute deviation. The third one is for sample variance. Beside it is sample standard deviation, and the last one is for coefficient of variation formula. As you can see in the table, this is the result I got from using Excel to find the measure of dispersion. The first one is the range. I got it from take the maximum value from the raw data and minus it with the minimum value from the raw data, and I got the result is 31.2 for the number of visit and 115.4 for number of purchase orders. For mean absolute deviation, I used the everyday formula in the Excel, and the result I got from it is 7.49 for number of visit and 25.66 for number of purchase order. I already round it up in my mind, so don't expect me to say each of the number like 7.44 at or 44444. Okay, and continue to variance. I get it from formula var.s to find the variance sample, which is the result is 76.10 for number of visit and 987.59 for the number of purchase orders. For standard deviation, I use the formula stdef.s for to find the standard deviation sample from the Excel, and the result I got is 8.772 for number of visit and 31.3 for number of purchase order. And the last one is the coefficient of variation. This one I use the standard deviation divided by mean. As you can see, mean for number of visit is 37.71 and the mean for number of purchase order is 166.82. So I use mean and standard deviation to find coefficient of variation. After I divide the standard deviation and divide it with mean, the answer I got is 0.23 is for number of visit, and I got the 0.19 for the number of purchase. That's all from me. Thank you.
Hello everyone, my name is Muhammad Rizwan Gandura, no metric BB22110711. For part 5, the question is calculate and interpret measures of association between the two metrics. There is two types of association, which is covariance and correlation. The formula for covariance is xy equal sum xi minus x mean multiply with y minus y mean divide n minus 1. And formula for correlation is rxy equal to covariance divide standard deviation x multiply standard deviation y. This table shows the calculation for x minus x mean, y minus y mean, and x minus x mean multiply with y minus y mean using Excel. From this table, we can calculate the covariance and correlation. For covariance, the sum of x minus x mean multiply with y minus y mean is 5130.6, then divide with 30 minus 1 equal to 29. The final answer for covariance is 176.91. Next, correlation. Using the correlation formula, we insert the value where is 176.91 divided with 8.72 multiply with 31.43 and we get the answer is 0.65. Since the correlation coefficient is 0.65, the value is closer 1 than 0. This means the relationship is a strong positive association.